Thank you all for coming. My name's Bill Hoffman. I'm going to be talking about C++ 20 modules. And I'm somewhere known as the CMake guy. Also the sandal running guy. That's me running 100 miles in sandals. And the kitware guy. I'm one of the founders of a company called Kitware. A little bit about me. I was, for 9 years, I was at GE Research and Development. And I helped move that group. It was a computer vision group. I helped move them from a symbolics list machine to C++ on Solaris and Spark workstations, and later Linux Windows.
Do they forgive you for that?
No, some of the guys, they just, probably still haven't forgiven me. But yeah, so I was involved in, C-front, C++, and I was always the CppNow Auto Tools guy. And in 1998, I left GE with some other folks to form a company called Kitware, and we've done lots of development in CMake, ITK, VTK. I'm mostly management now, so pointy-haired boss pitcher, and I spend my days, trying to find funding for CMake and keep people like Vito happy, so they have fun, interesting stuff to work on. CMake is a community effort. I mean, I'm hardly the CMake guy anymore. Brad King, Ben Bokel, Craig Scott, Daniel Pfeiffer. I mean, these are all CMake guys. Quick thing, Kitware does a bunch of other stuff besides CMake, believe it or not. We've got computer vision, data analytics, scientific computing, medical computing, and software solutions group. So it's a big open source thing that cares about building software. I always like to throw this pitch, especially today. CMake probably wouldn't be around if it wasn't for some funding from the National Library of Medicine. And the funding of this Insight Toolkit from the National Library of Medicine for the Visible Human Project. We were part of a team that was to create this new C++ project to do segmentation of registration of medical data. And we were creating this code, and it wasn't actually in the statement of work that you should go out and create a build system. It was just something I wanted to do, and we happened to have funding. And it probably had a bigger impact than the Insight Toolkit itself, the fact that we did this. And it was somewhat related to the project, because the project involved codifying the state of the art in segmentation and registration in C++. So that grad students didn't have to keep re-implementing papers over and over again. They could just use this big library. But hey, if you create a 1,000,000-line C++ library with a whole host of libraries in it, and you say to a grad student, use this, he might think, it's almost easier to rewrite this paper, because that's what the state of the art and build things was back then, right? I mean, it was just cobbled together make files and maybe Visual Studio project files that were checked in. And if you wanted to write a small program that used a couple different things, and maybe, hey, you wanted to use VTK for visualization on top of it, you needed some tool to help you do that. And that's where it came from. And since then, I've begged, borrowed, and stealed and found funding anywhere I could to continue the project and build up the community. And it's been really cool to see. Backwards. All right, enough of the background. Let's talk about modules. That's what we're going to hear about, right? All right, so in the context of this, I'm going to be talking about name modules. Back in 2023, Daniel Russo talked about the challenges of header unit modules. Personally, I think that that name modules are enough and provide enough of challenges on their own, and that we can get that backwards compatibility. And I'll be talking about that in this talk of how we can do that backwards compatibility without turning every header file into its own weird module. All right, so gave a similar talk back in 2023, and I said, hey, ChatGPT, does CMake support C++ 20 modules? And it said, sure it does, and it gave me some garbage here that makes no sense, doesn't work. Although they're violating Brett's standards all over the place. And in 2024, I said, Try again, tried it again, and it had some good comments in there, but when it actually came to writing the code, it got it pretty wrong.
It's a different module.
So 2025, still no luck. It did some weird things like set CMake experimental module API to experimental. It did have some nice comments there that kind of made sense. So it's learning. So I don't know. One thing I take away from this is there isn't any CMake code with modules in the wild, which is why it can't learn how to do that. So maybe we can work on changing that. That's what we're doing here, right? So to talk about how modules work, when the compiler sees a module, it creates a built module interface, a BMI. MFC, this would be an IFC file. GCC, it's a GCM file. Clang, it's a PCM file. And the idea is this is almost like a precompiled header. It's the module interface. So let's look at a simple example. So if I have a that exports module A but imports B, and then I've got B that exports B and creates this function. So build order suddenly matters. This is something brand new to C++. We could be embarrassingly parallel in the past. We could compile things in any order we wanted. I mean, until you tried to create a library or an executable, you had to have all those things. But the order of the building the object files didn't matter in the past. But if I just switch the order and build B first, then I can build A because the B's built module interface exists now because it was a byproduct of that compilation. So this provides a unique problem for build systems. Because a module requires the build system to know which files produce which BMI files and which files consume them. So producers and consumers. So how do we know this? Well, we're going to have to parse the files to find that out, but then we have to compile the files to find out if we can compile the code. So that's obviously a conundrum. Fortunately, CMake solved this problem for Fortran. So modules are not unique to C++. Fortran actually had them going way back when, like 2005, we added the initial support in CMake for Fortran modules for makefiles, and then eventually we added it to Ninja in 2015, and we had to modify the Ninja build tool to handle dynamic dependencies because the build graph had to change after CMake was done running because we had to run these parse steps and then modify the build graph. So we had this Fortran stuff. We talked with the Ninja folks, and they were moderately interested in what we did. They loved the code. They kept saying they'd merge it. But until 2019, because C++ was adopting modules, they said, oh, we care about C++, so we're going to add the support. So, if you want to look it up, there's this, in Ninja, we added this dynamic dependency to support this. So how does CMake do it for Fortran? Well, the Fortran, CMake actually has a mini Fortran parser in it based off of a program called MakeDep F90. For obvious reasons, it is not a good idea for C++ for us to put a mini C++ compiler inside of CMake, or even a large C++ compiler inside CMake, or any C++ compiler. I know, we could use regular expressions. But no. So we really need the C++ compiler to help us out here. So we've patched Ninja, and we've got our dynamic dependency, but we've got to do this parsing. So Ben Bakel put a paper out describing how CMake did Fortran modules to the tooling group, explaining how this could work. And this eventually led to P1689, which was a format for compilers to give this specification. So I can ask a compiler, what are the requires and provides of this C++ file? And it can do a quick parsing of the file and give me that information. So this, for each target, it goes through each source file. Yeah.
Sorry.
Sure.
What's the kind of granularity of the information in these files? Like the provides, for example, is that functions or?
No, modules.
Just
the modules.
Okay.
Yeah, so if you've got a export B, it's going to say I export a B. If you say import B, it's going to have an import.
Fancy then.
Yeah,
Really
pretty simple. Really simple, but again, it was necessary evil to get this, and took time because we had to get all the compilers on board.
It's fancier than Makefile files.
What's that?
It's fancier than the Makefile equivalent, right?
Yeah. The other question there? Yeah, I thought I saw a hand. Okay. So where are we today? In Visual Studio, the latest versions have this implementation in it. Clang 16 and newer has it. GCC 14 has it. CMake 3.28 has support for name modules. 3.30 to 4.0, there shouldn't be a dot there, has experimental support for import std. So I think we're in a pretty good shape for name modules if people want to start trying it out. The CMake module able generators would be Ninja and then Visual Studio. Yeah, sure.
One thing I was wondering about, so yeah, we're talking about the fact that it has to scan the files to find like the dependency graph between the module imports, and like what order things are going to have to be built in. If you're using this at like a large scale code base, is it going to have to basically parse every file twice? That was just something I was just thinking about now. Yeah, I figured so. Yeah, it'd be interesting to see what the performance impact of that'll be, because obviously the hope with modules is that it makes the build faster. So it'll be interesting to see.
The expectation is the first parse can be immediately parallel, and it's faster than a full parse.
Right. It's not a full.
So it's mostly certain
not like a
stages
full
of the
parse.
preprocessor doesn't actually have to parse in C++ per se.
Okay. Yeah.
Hope this doesn't derail things, but on the same vein, do you know how much faster the scan dependencies run is than just a normal parse? Is it orders of magnitude, or is it?
I think it's orders of magnitude. Yeah.
Multiple orders of magnitude? Wow.
I mean, I haven't done the actual time, but it flies by me. It's not.
It doesn't try to understand your template metaprogramming.
Sure.
The reason the compiler needs to do it is because CMake doesn't understand the C preprocessor.
Yeah.
That is like the core issue that we faced was like, I don't know if you define these internal GCC macros because I don't know what compiler you're using.
Yeah.
So the biggest problem was getting over that preprocessor hump. There's no code gen, there's no AST, it's just run the preprocessor and then figure out what the imports and exports are and then get out.
No, I mean, it makes total sense. Like, I'm not saying that, like, I agree with you, let's not put a C++ parser inside of CMake. It'll be interesting to see what this looks like.
The expectation is that the ordered build graph is probably going to matter more than the scanning stuff.
Yeah. Okay, cool.
Oh, I mean, just to play devil's advocate, you could have, like, if you know what the compiler is, you could invoke it to preprocess the file, right? And then read that.
And that's effectively what the scanner produces. We just also pushed off the JSON generation onto them because we could.
I think as implemented, they'll skip certain preprocessing stuff.
Yeah.
All right.
They won't do a full preprocess, if I understand things correctly.
Yeah, I think there's some optimizations in there. So if you wanted to see what one of these files looks like, this is from Microsoft running on that simple a.cpp, and you can see that it provides the logical name A, and then it gives a source path to the module, and then you can see it requires logical name B.
So the provide is the export and the requires is import?
Yes. And then if we run it on B, you can see that it provides a B, but it doesn't require anything. And it shows what its outputs are. Okay, so that's sort of, any more questions on like the scanning basic stuff? Yeah.
And the scan will not show any like what kind of headers it's including, right?
No. I mean, I think during the step, it actually does create the header dependency graph as well.
Any reason why it doesn't include it here?
Why would it do that and throw the information away?
Yeah.
It doesn't throw it away. We're store it somewhere else
Oh, okay.
in a different file.
Oh, so it is available.
What do the version mean?
It's the version of this JSON file.
We discovered that all files must be versioned under all, like, because you say today, this is it. This is all the information we'll ever need. And then 5 years down the line, it turns out that assumption was wrong. And so that's why we put versions on everything these days.
Interesting. Okay.
Out of curiosity, what's in the way of the Xcode generator also supporting this?
Talk someone to Apple.
Apple can give CMake a pull request,
Sure. Okay.
or work with Gitlab to make one.
Yeah, I think just demand. Yeah, like I'm not even sure all the changes for modules have been upstreamed into Apple. I mean, they're upstreamed in Clang, but
Apple Clang is not the same.
Apple Clang's different.
So Apple Clang doesn't support this?
We don't know.
Oh, okay.
Don't think it does right now.
They're perfect.
All right, so jumping to file sets. If you saw Brett's talk, this is since CMake 3.23 is a way of specifying a group of headers. And we'll see this is sort of interesting. So this is a header-only library with file sets. I'm saying my base stir is source, and then I give it a list of files. And then when I go to install, I just say install file set headers, destination include eigen, and then
Sorry, you say base stirs is source. I can read that, but what does base stirs mean? And did you already tell us? Did I sleep through that?
Base stirs is it's the relative. You can do.
It's the include flag.
Yeah, you can do the include flag.
yeah, the -i flag essentially, the base of where everything.
Okay.
Actually, maybe if I go
And
to
so
the.
I mean, it was confusing example because there's also source in the file paths, and so they're in source/source or something.
On that repo, yeah.
Yeah, for that repo.
No,
So,
no,
okay.
sorry. Back up one slide. We can fix this.
We can break it down.
So, base stirs can have multiple. You can have multiple base directories.
Sure.
So you can have 5 of them, right?
Yeah.
And that translates effectively to include directories. We're gonna say that for now because it's an easy enough simplification. If I had 3 base directories, right? Let's say I had source, include, and Vito's cool directory. When I list my files, I don't know which of those base directories that a given file is supposed to be relative to. So I actually need the path to the file.
Okay.
So it's not source eigen.h, it's just source eigen.h.
Oh, okay.
and then when you do the install, you can see it's putting it in the install directory, and then it's just include eigen.h. So it's stripped off that base.
It makes a data structure that defines all sorts of properties, including like what the include statement is supposed to be spelled as, so that it can do an install correctly. And that includes both in the build directory and in the install directory. That makes sense. Like you'd have include paths for both, and like it's a full model of what you've been doing this whole time instead of just flinging flags around and hoping for the best.
It's nice.
And where this comes in, there's a little background that I poorly delivered. So file sets added CXX modules as another type, including headers, which works similarly, except this is how you'd specify our A.cpp, B.cpp, in that we're creating a new file set called CXX modules, and it's a type CXX modules. And this is what you need to do to let CMake know that there are modules inside these files.
Because there's no standard for that.
Yeah.
Sorry, do you understand correctly is that This just says somewhere import or export somewhere inside of these files.
Yes.
Okay.
No, export specifically.
Import as well, because it needs to scan.
No, but you need to scan the other stuff for imports too.
We scan everything.
You have to scan everything because you might have imports and headers or whatever. But this specifically says these can have exports. So you need to make BMIs for these.
Okay, if I send a file that doesn't have an export, is it fine?
You don't have to list files that do not have exports.
Right, because, okay, so the trick is these BMIs, right, to generate a BMI, you're going to have a.cpp. And you're going to have to install that source code somewhere because you might need to compile that BMI as a consumer of the library to use that module.
These are analogous to your public headers.
But this is telling CMake to take a.cpp and create a BMI.
Right. It also knows-
But if you had another CPP file that imported something, you wouldn't have to create a BMI for it.
Right.
You would need to scan it to see if it needs to.
It'll show up in the scanning thing, and then CMake will know that it's an importer, and it needs the import needs to be built first. And all that. Yeah.
Right.
So it's again a full model
Can I ask what is a BMI?
It's an excellent question. Bill, what's a BMI?
Binary module interface.
of, I think it's built modular.
So,
Built
sorry,
what?
just to follow up, why do you need that if you scan everything anyways?
You said that. It's just a precompiler.
It's an export of the AST, give or take.
Okay.
Yeah. And it's also not it's very finicky in that changing some compiler flags, even though they have
Right.
ABI compatibility, may not have BMI compatibility.
Right.
So you definitely need to have those source files around because you might need to rebuild that BMI.
Isn't that what the paper you showed us was about? Standardizing
No.
that was a different thing. Okay.
Yeah, that was for standardizing compilers to give me my requires and depends.
BMI in some cases is almost exactly a byte-wise dump of the compiler state for that file. So it's very finicky. It needs to be emphasized.
Before CodeGen.
Before what?
Before CodeGen.
Before CodeGen, yes.
So the answer to the question of why do you need to list your modules, it's for the same reason you need to list your public headers. You are telling CMake, this is the interface to my code, and when you install this, when you ship this library, these are the source files that need to ship alongside it.
So for installation.
Yes.
Okay.
There's private modules too, but that's the important one.
Stop.
For it and compile it, and it needs it at compile time as well.
If you were, I know it's foolish in this day and age, but if you were willing to lock down, what compiler flags your clients could use, presumably you could leave the CPP files out, right?
If you're willing to lock down the compiler itself alongside, yes.
Yeah, sure.
And another way to phrase it, in a controlled enough environment, you would not need the extra metadata. That's what
But that's metadata. They're just plain source files, right? That you wrote.
well, you need the scanning and the ordering and the build still.
No, these are just source files.
No,
Yeah,
I
so
mean the
it's just source
CPP files.
Yeah.
So I wasn't talking about metadata. I was just talking about the source files.
I mean,
Bill said you might need to rebuild it.
Right.
And I'm trying to understand the contingencies. Is it possible to arrange a scenario where you wouldn't need to rebuild it?
Yes.
You would have to lock down your compiler version, flags,
if you
everything.
if you have
Yeah,
a very
okay.
hermetic, reproducible build environment, then yeah, you could cache that kind of thing.
Is that where the finickiness comes in?
If you have to be at the level like a Bazel style build system where everything's hashed and any little jot or
Yeah.
tittle change,
Yeah,
you
yeah.
do everything.
Okay. Thanks.
Just as a follow-up, why the scan, when you scan, you know which files export things. So why do you need to tell you, this exports things?
Because just like you have public and private header files, you can have public and private interfaces. Interfaces you don't want to install alongside.
Also, you associate the modules with the library, and the library will have build properties on it that need to apply to the modules. This compiler doesn't know that stuff. The compiler can't even scan these files until you tell the compiler that, hey, I have these include directories, I have these preprocessor definitions, et cetera, et cetera. This wires that up too. So you can't even do the scanning until this is set up. Does that make sense? Like your modules will be including header files, and like for the modules to include header files, they have to be search paths. For them to have search paths, you have to have it associated with the library target that has target include directories. So like this is precursor to even scanning. Or maybe that didn't make sense, but maybe some Dino guy over here already knows this stuff.
All right, and then yeah, you can go here and compile it, and everything just works. Here's the compile line. You can see here what's going on. So it's running the Clang scan depths with the format P1689 and generating the file in there. And then once those are done, it runs the CMake -e ninja dyn-dep command to consolidate all of the dependencies that it's just scanned. So this is just basically showing a build out command line, yeah.
Without the format flag, it wouldn't be compatible with different compilers? Or what's the point of that?
That's to ask the compiler to give it the structured JSON back about the dependency graph.
Okay.
That's to say, I want to use that nice interop layer that was already defined as a standard. If that didn't exist, CMake would have to handwrite code for every compiler or implement a C++ partial like build.
Wouldn't this be the default though?
Well, no, this just happens to be the command line. This is how I ask Clang to give me that file.
Okay.
So regardless of having the format thing, this is how you ask Clang. Microsoft is a little different.
I forget what Clang scan depths default is.
Yeah.
It's something dumb.
I think it has its own JSON format for default or something.
Yeah.
Or it might be it might even be a module map file, which is a whole other thing.
Yeah.
And in furthering this, the install target gained a CXX modules BMI. So any module from a C++ module in public sources of file set type CXX modules will be installed into a given destination. Pretty straightforward. So this could bring it, so if you got a large project that had some small bit of modules, you might not want to pay for that scanning everywhere. So there is a way of turning it on and off. It must be on for any file that has an import and export, obviously, or it won't work. But you can turn it on and off. Note that scanning is only performed if C++ 20 or higher is enabled for the target. Yeah?
Is this a target property or this is a global flag or it's both?
There's a global flag that'll initialize the target properties.
Okay, but it is also target property.
But it could also be done just strictly target properties.
Perfect, thank you.
When you export targets, you can give the CXX modules directory. So if you look at the anatomy of a name module, this is kind of important for understanding modules. It starts off with this module semicolon, and then which is the start of the global module fragment. And inside here is where this global module fragment is where you can include C++ files, C files, turn flags, things like that. So that's where you do non-module type stuff. And then you declare the module. So I'm saying I'm export module A. And then after this, it's expecting everything to be modules. You can include files inside there, but those files can't include like regular C files. They can only declare modules. It'll make more sense a little bit when I get to a later slide, but this is the basics of a named module in C++. So any headers included here must also be in your public interface because the module will need to be compiled to create a BMI by consumers. So if you have any header files like foo.h inside there, they're also going to have to be in your public headers.
You're doing all this. You're doing all this kind of scanning stuff. Why make people write that in the build files?
Doing.
I mean, I'm I'm obviously missing a lot of detail, but if I understand right, like this whole system has to process a lot of source files in order to figure out how to begin building stuff, right? Like has to process dependencies, et cetera, right? And you just said, if you include anything at this point, you have to also write that in your CMake file. And I'm always like, if the computer knows I have to do that, it should just do it for me. So why not?
You need to put it in the structure that you intend, though. So that header file could be in any number of libraries that you have inside your project.
Mm-hmm.
You have to say, well, it goes with this one, and then installs it this directory. So like you're going to need it in your metadata anyway. I think Bill's comment's more like, don't make it private or things will break because you just made it private and then you ship something that's using it. Does that help?
Okay.
If you don't make it public, then when you install a library, it won't get shipped and installed.
Right.
Installed. You have to explicitly say, hey, I'm referring to this as part of the public interface of my library, so it needs to be installed.
But yeah, my point is like you want ownership of every header file anyway. So like that's not for free. Like because again, you might have 5 libraries in your project, and it makes like which one.
But it's just making it clear that this is part of the public interface for the project. So any header files in there need to be part of the public interface of the project in the normal way that you do public header files for a project, regardless of modules or not. This is adding anything in this global module fragment is part of your public interface, and you're going to need whatever's in there to be installed alongside. If you're going to play around with this stuff, you're going to have to know about experimental.rst and the CMake. So this basically is the experimental features. Right now, name modules are not experimental anymore. Okay? Import stood still is. So you'll want to go here and up in the corner up here, it's got the version of CMake because these experimental hashes change with CMake versions. And you can pretty easily, if you're playing around with this stuff, shoot yourself in the foot by using the wrong hash that doesn't match the version of CMake you have.
This might be funny. Is there unnamed modules?
Yeah.
Okay.
They're called like importable header units.
Which is like?
It's like a header you can import.
Interesting.
What was that?
He's saying, are there unnamed modules?
Oh.
I said, yeah, you can import a header unit. You can import a header.
Right.
Unit.
So yeah, named modules are what I just described.
Okay.
In the C++ standard, there are header unit modules, which were meant to be like a transition.
So instead of prime including, you do import a header.
Exactly.
Right, and it automatically just does magic module stuff
we
to
talked
your old
about
.h file.
Modules is just the named modules. What you just
Yes.
Okay.
Magic module stuff. Sounds reassuring.
But header modules are even more complicated for the build system than named modules.
And unfunded. More importantly, someone needs to work on it.
Yeah, and they're not implemented anywhere.
And would that treat the includes in the header file as modules or regular includes?
There's a lot. That's a whole subject. We can get into that a bit, but I'll let maybe we can get back to that afterward.
Yeah.
But those are good questions, though. Yeah.
So to play around with this, you're going to want to get a new compiler. I'd recommend getting the newest compiler you can find. If you're going to build a Clang, you want some command line, looks something like that. Grab the latest CMake, set up some environment, make sure you're pointing your compilers, play around with the CMake install prefix. And there's this cool web page here called Are We Modules Yet? The answer is
No.
no.
That's not estimated by 2026.
Yes.
So it's kind of cool. It's got a little checkbox you can check and show the ones that have it. And I kind of looked at these. I'm like, okay, cool. There were like 17. I'm like, all right, you're telling me there's a chance. 17 libraries with module support. Let's go build them. So I started playing around and trying to build a lot of these, and it was kind of a magical mystery tour. Lots of fun times, and running into weird errors and bad CMake files, and a lot of these, the ones listed there, kind of have modules. I went down a deeper rabbit hole with compile time regular expression library. Ben and Hannah and myself kind of went back and forth the last time I gave a similar talk on this. And we made some good progress. First thing I discovered, there was no install for the modules. So I said, oh, no problem. I'll just add like a hello world that inside the project, just add another add executable. And that didn't work. And I dug around, and it turned out the CXX scan for modules was the culprit because it was set to off in the project. That was fun. But we worked back and forth, and here's the C++ standard. Trying to figure that out and get the correct scanning for modules targets working everywhere. And then we actually did a PR to add install for it. And then I created just a little hello world that would do import std, import CTRE, and created a little CMake file here, which just, again, turned on our experimental import std. And if you copy this code out of here and run it with CMake 4.0, you'll get errors because the experimental hash has changed. But the basic CMake code is the same, and then I can build it on MSC and Clang on the Mac. So cool, got something working with modules. So if you're going to play around with this stuff, you're going to run into, you'll probably see this error, especially if you're playing around with import std. Turned out when I was playing around with this that the Clang has a way to ask for, right here, minus print file name equals lib C++ modules JSON, which is supposed to give you the path to where this file exists, which is essentially the information for where import std is defined for the compiler. And it wasn't working unless you gave it some extra ... slashes on the path. So I kind of hacked up my CMake to get it to work. But I filed a bug report with, it was a bug report in CMake. Actually got on Clang, filed a bug report, went down a long rabbit hole, and finally got it implemented in Clang now. So that's actually fixed. So yay, we're making progress. Okay, so some other things you might see is the same error, someone else's fault. So in this case, if I comment out the experimental hash before the project file, I'll see this same error. And what it's saying is that this the magic STD target doesn't exist. And then here, if I stick it after the project command, it gives me the same error because the project command is the thing that initializes the compiler. And if I haven't turned this experimental feature on before the compiler gets initialized, you end up with this error. This is actually improved in CMake a little bit. Now it gives you an error that says experimental import std is not enabled when detecting the toolchain must be set before CXX is enabled, usually in a project call. So it's giving you a much better hint now, but you still might see this if you go playing around with it. You'll get that same error if you just either don't have it or you set it to the wrong value. So, another hint, if you're playing around with this, blow away your build tree every time because CMake remembers when it didn't find it and it doesn't try to find it again. So you might go in there, change your code and have the exact right hash, and then it fails on you again.
Does the cache claim fix that?
Yeah, it probably would. If you see this, that means you got it right. You got a nice warning that says this is a new experimental feature. So this is good. And hopefully we'll get this out of experimental. And then, yeah, go ahead.
Other than import std itself, is there anything in CMake's support of named modules that requires C++23?
No,
Or is it's
20.
just import std?
C++ 20 is what.
Okay, great.
Because everyone agreed to backport it, so we can say that, okay, since all the compilers said we will support it, we can in CMake also say we support it at C++20.
Import std itself?
Yeah, import std.
Okay.
No, STD is 23.
Oh, is it 23 still? Never mind.
Yeah.
Take it all back.
Name modules are 20.
Yeah.
STD is 23.
Okay, so all this requires experimental. Fine. This modules came out in C++ 20, right? So is there another build tool that works for C++ modules that isn't experimental?
Okay, so
if not, what's the big picture story about why the 5-year gap that everybody's not there?
So we are there with just named modules. The only thing that's still experimental is import stood.
Okay.
And that's because GCC still doesn't have one. Only Clang and Microsoft have it now.
Okay.
So we want to make sure that we were kind of waiting on GCC.
Okay.
It's happened that a toolchain implements things a little weird and they have to add a little more complexity to account for that. And we want to make sure that they can break the APIs if they have to.
Sure.
Right. So if GCC decides to do it some way that's completely different than the other two, and we have to some reason change our API or something, then we want to reserve that right. But if you just want to play with name modules, that's out of experimental and it's been out for.
Very cool. So do you know if other build tools are handling it, like Bazel, for example?
Bazel has it experimentally. So Ben Bakel's been working with them. Someone had tried to do a merge, and then the Basil people were like, "No way, we don't want this." And he's like, and Ben went to them and said, we have this experimental thing in CMake that allows us to do things so that if it should change down in the future, then you won't have to support it. And they were like, "Oh, that's a good idea." And they added an experimental feature. And it's in there. I think.
So what did C++ do wrong that's making this so hard for people? That's like I care as a language developer. I'm trying to figure out.
Well, so when the standards committee first said they were doing modules and they were going to look like Fortran modules, I was terrified.
Okay.
Because I'm like, we went through this with Fortran, and we kind of did it wrong, right? We have a Fortran compiler parser thing in CMake. So imagining having the amount of work they would do, I think it got implemented, but it got put in the standard without much consideration of the tooling.
Being able to more quickly identify properties of files would have helped a lot. Like having standard file extensions, having the names of the modules mapped to the names of the file somehow, that would have helped a lot. They did a pretty good job on keeping the scanning requirements contained to the top of the file. When Bill was talking about the global module fragment, those are all features to make it easier to do the quick scanning that we were talking about. They could have, I guess in theory, they could have done something like what Gabby Dos Reyes was wanting to do, where they had some kind of standard for the BMI itself, and that itself is somehow more portable. Although there's big questions around that, so I could see why they didn't. But I think the biggest thing is just we didn't have enough implementation done before the standard landed to be confident that we landed a reasonable amount of time.
The old story.
Yeah.
Okay.
And this was more it was in this part of the system. Again, people in the ISO meetings are usually compiler engineers, although they're a minority. Library authors or language designers. How many build system engineers were designing this thing? And the answer is very, very, very few.
Yeah, you can't really do modules without a build system integration.
Yeah. So having more build system engineers in the loop when you're doing things that affect the ecosystem is very helpful.
Yeah,
and
that makes sense.
There's such a huge gap between the way the different compilers ended up looking at BMIs that caused issues that were kind of unforeseen, right? We were talking about all this fragility surrounding the BMIs and how you can't ship them and you need these hermetic builds. MSVC, who were big proponents of the earlier modules work, don't have those problems. They ship widely compatible BMIs. It wasn't until Clang and GCC kind of came around and said, okay, we're going to implement it, but these are our restrictions that we then realize. So, you know, dogpiling on not enough implementation experience. It works in one compiler, but that doesn't mean it works everywhere.
Right. And to this day, EDG still doesn't support everything entirely, which is why Microsoft IntelliSense doesn't work with modules.
IntelliSense is using EDG's compiler to do it.
That's my
Yes,
understanding.
yeah, that's the front end.
Awesome.
But I think it's also because it does require such a coordination of different groups and people, right? You've got to get the compiler vendors on board. You've got to get the compiler vendors to agree to what needs to be done. Then you've got to get them to do it. And then you've got to go to all the different build tools and get them to implement it and get them to agree on how to do it. So it takes a long time. I'm not exactly sure how you could have made it faster, other than doing maybe like earlier prototypes of it.
Hiring people to do it more would have sped it up.
Okay.
But there's a lot of time. There's a lot of gaps where just no one was working on that problem for that year, or that 6 months, or that 18 months, or something. So.
I don't. If you have other things on the agenda, I don't want to like derail this whole thing. I have one more question related to that, but I can hold it if there's other things to get to.
I have a comment. When Java 1.8 turned into Java 9, they were also introducing modules. The migration was also very painful. I think till this day, all the build system basically ignores it still. Gradle, which is Java's CMake, come out with almost exactly the same timeline even. This is experimental. Even though Java has like way, like everything on Oracle, it still takes a long time for everything to propagate. And you can't really orchestrate it as like a language effort unless you plan to work on this for 30 years is what my take is.
All right, well, let me move on, and then if there's time, there probably will be. All right, so yeah, winner, chicken dinner. We got like a couple things that worked out of this for me anyways. I did a little thing, apparently $2 was the standard bet for many gamblers. So if you won, you could get a free chicken dinner. Anyways, so I just wanted to explain what winner, chicken dinner.
You put off my coding question to say that.
All right, so 5 more projects have, we'll get to your question.
Fine.
Since the last time I did this a few months ago, 5 more projects have been added, which you can see we're up to 22 now at a current rate of 4.47 projects per year, which puts us at 2555.
I think 75 years sooner, though.
Yeah. So I'm dubious, but we'll see.
20 years of project.
In looking at all these projects, I kind of learned that why don't people format their CMake code? I don't know. Just why? Goofy spacing, tabs. They think it's make files. I don't know. Be really careful with the versions of things. A wrong version of CMake, Ninja, or compiler can result in the vomiting of not so useful errors at build time. So don't despair code. Import std will pave the way. So there's a blog up on Kitware about import std in CMake 3.30. The new experiment, which is still experimental. But in looking at import std, it's essentially a name module that's built around existing header files. So let's take a little look under the hood. That's my dog trying to get into my car and doesn't realize you can't get in from the front hood. So if we look at import std in CMake, this is in the experimental file. Tells you what value to set the variable to, and then the target property cxx module std is initialized by CMake cxx module std. So targets with this property have to be at least standard 23 to use import std. So I'm calling this the import std model, which is name modules for existing library. without too much changes to the existing code. So we need to maybe create a file like std.cppm. So what goes in those files? So I took a look at Clang, and you can see it's got our module declare at the top, and then the module fragment, global fragment with a bunch of includes, and then we say we're exporting module std, so we're naming our module, and then we're including all these .inc files. And if I look in one of those INC files, it looks something like this. Export namespace std, and then does using on each of the things that are inside those header files. And I believe the Clang folks used a parser to go in and generate this file. So this is a generated file, so that's the way Clang's doing STD.
You check it in.
Huh?
I think they commit it.
And then they check it in, yeah. They run it, and then they check it in. So what does MSVC do? So I looked at theirs, and they've got their module and their global thing. Got a weird define there, that build standard module. I wonder what that does. And then, lo and behold, they're just including the actual files. So now I'm like, what kind of witchcraft is going on here? So I look at it, and if you look in the vector class, you can see that they've got a macro there called export std. So they've learned from the same thing they do for shared libraries, they did for modules, which is kind of cool because by modifying those files, then now they just reuse those files. There's no parsing involved. And they're just reusing those files with this simple macro, which is kind of cool. When I expand that out with the C preprocessor, you can see it's saying export for that particular file. So that was kind of cool. So now we'll take a look at what it takes to use import std from CMake. So you got to have a minimum required. It's got to be 3.29 this date or higher. No reason to use that crazy thing anymore. It's just an older slide. Set your experimental thing. This has to come before the project command. And then I'm setting the global flag CMake CXX module std, which will then tell any other targets here to initialize that property to be on. I'm creating a target here called uses std, which has a CXX file called usesstd.cxx, and it's got a private interface of using standard 23, but its public interface is 20. So then I create an executable, and I link it here. And since the the public interface for uses std is only C++ 20, my main can't use import std because it's not up to C++ 23. But it can use a library that is doing import std.
So in a way, if you just remove that line, you can just have import std for C++ 20. Is that what you're saying?
He's saying you got different flags for the different objects, and that's one of the nice things about name modules. So probably more common would be private includes. You don't have to corrupt your main CPP file with the includes that are only needed for that module interface.
Right, but C++ 20 has everything you need to do import std. So just by removing this flag,
it doesn't, because the compilers don't.
I was wrong. Ignore things I said. Okay. I think I want to revisit this issue in CMake because the compilers have committed to.
It was not about the comment, but the fact that he said you can use a library that uses import std.
Yes.
But your main is compiled with C++ 20.
And C++ 20, and when you set up C++ 20 in CMake, it does not support import std. It only supports it on targets that say
23.
Okay.
That might be the other. We might be able to relax that.
In terms of just sitting down and actually using this, if I went and got the most recent version of Ubuntu or something like that, do you have any idea how far along we are in terms of supply chains actually shipping tool chains that have versions of libc++ that actually support import std?
Yeah, if I did like brew install Clang LLVM on my Mac, it would get.
It does come with this.
It does come with this.
That's
yes.
very cool. Okay, thank you.
Is Debian unstable? I don't think it's.
Didn't Simple probably have it? Arch distros will have it. I'm not sure about Ubuntu.
Yeah, I mean, I picked
Just
that
go
up.
to
man,
distro.watch.org
but-
and look it up.
Cloud has their own release APT, and it's really up to date.
Okay.
Again, from there. GCC, good luck. There's some Ubuntu default actually give you a pretty up to date GCC if you ask for it. But that depends on your Ubuntu level. We can talk about this later. That's a helpful. But I have a question.
Yeah.
Can you talk more about the target compile features? What does it mean by I primarily depending on Silver 23, but I'm publicly saying that. So if somebody compiled this with Silver 20, would there be two versions of SCD in the compile build, or I'm kind of not getting like what does it mean by we can have like a private and public?
What it means is to build it, I need C++ 23. But to consume it, I only need C++ 20.
So link time I only need Silver 20. That this is or.
We're getting into all sorts of things about transitive dependencies.
Okay.
The straightforward answer to your question is what's going to happen here is because uses stood has said it requires C++ 23. When that translation unit is compiled, there'll be C++ stood equals or stood equals C++ 23 for uses stood.cxx. Right? So that's one translation unit.
Okay.
Am I wrong to assume that
You can
if
draw an
the library
analogy with
uses-
header files. It's pretty.
Yeah.
It's pretty straightforward. Like
if the library
think
uses
about your.
C++ 23 feature, then you wouldn't be able to compile the main with a C++ 20.
No. Here it says use std publicly only C++ 20. So it doesn't contain anything publicly. C++
It's
23 things. You will not see them.
You can think about it like it had a public header file that only used C++ 20 features.
Okay. So
Your C++ 20 compiler can consume
But
that
it still
header
has
file.
the import STD bit of it.
No. Because that
Oh,
import
I
STD
understand what
disappears
you're
once you
talking about.
compiled it into a binary.
I see.
Yeah.
Okay.
There you go.
Okay.
But
The source file uses C++ 23.
But don't do that. There's other reasons.
Yeah. The other reason not to do that, very confused example. Moving on.
Yeah.
Plowing right
I
along.
think private headers, that's what I said, private headers is a great example.
Yeah.
It's like, you don't need to know about their headers, they don't even have to ship them, stuff like that.
right. So if we look at the source code that went along with that, inside uses std, we can see it does import stood, and then prints hello world. And then now in the main, we're calling hello world. So
Yes, of course it's a joke.
okay, so what happens when we compile this? You can see here, I'm sort of showing this is essentially it's CMake is creating a hidden library to you called the CMake cxx23.a library. So that's where the stood.cppm file gets compiled into, because it needs to be actually linked on several of the compilers. So it's creating this hidden target for you when you specify that you need to do import stood.
Probably said you didn't have to do that, but we can move on.
You do have to do it, unfortunately. Yeah, we tried not to do it, and then I think several of the compilers did not fail without having to do this.
Yeah. Well, it's more than ergonomically unfortunate. It's actually, we can move on.
Okay, so there's a couple ways to look at this and to do this. So in working with modules and headers, if you wanted to move a project to have a module interface to it, you can do the manual sort of using GLM was one of the are we modules yet that did that. Generated using, which is what Clang did with its import stood. And then the define module export I saw this in MFC's doing it. A couple Boost libraries are doing it that are in that are we modules yet, and the compile time regular expression's doing it. Or you could just write pure modules and not have header files at all. So this is GLM is doing this. To me, this looks really hard to maintain if it's not a generated file, because if you start changing the header files or changing your interface, you're going to have to constantly go back and change this. So this seems a little bad to me. I really like this approach. So in Boost PFR, it essentially does the same thing Microsoft is doing. So inside the, so basically they've got their module and then some includes. And then you can see here they're doing, if they're doing it as a module, then they import std, otherwise they pound include. So the tricky part with this is this header file here needs to not include other header files like standard, yeah.
Just a question, like if you, let's say you did import std, and then you include a header that includes array. How does that affect compilation speed, if you know? Like, will that header for array still have to be processed and stuff, or it can be somehow skipped?
I think they might be incompatible with some of the compilers, so you can't do both.
You showed an example where you did both.
There is outstanding bugs where
there's an outstanding MSVC bug that says don't do that.
If you find a compiler that doesn't successfully do that, find a bug that exists or make one that doesn't, because we're never going to get modules unless they fix that. Because you can't control like your includes and what they include.
Yeah.
All right.
Okay, so.
Is it faster? It's broken. Gotcha.
Yeah.
All right, so I wanted to play around with Brett's Beeman exemplar. So I did a pretty hacky version of creating a identity.cpm file where I start the module. I define this, I want to build it as a module, and then I export module exemplar, and then I include the identity.hpp, which I hacked up to now have, if we're doing build module, I'm going to do an import std on it. And I'm also going to pound define export as export. Else I'm going to define export as nothing, and I'm going to do pound include utility. And then, so we do namespace Beeman exemplar, and we do export in front of each of the items in here. And then change the CMake code by adding the CXX module to a file set, add target sources, and then add it to the installation as well. And this did actually compile. So it's pretty rough, but I think we could come up with something that provided a modular interface to it. Yeah.
Can I just ask a question? It's more like about future of CMake development. But in this case, right now, we don't specify any headers. We only specify one CPM file, right? Technically speaking, if you take the cargo and Rust, where you have like, when you create the library, you have a lib.rs and cargo toml. Could we have something similar, say CMake toml and my lib.cppm, and that's it? Because right now, if you look at the exemplary, there is so much CMake, even though very declarative, but a lot. But it feels like the only difference between all of these libraries with this template would be the name of that CPM file.
Yeah, and where it lives, right?
Yeah.
Yeah, so that'd be awesome. Anyone else got $2 million? Like, yeah, it would be awesome.
So if I have a 7 PR tomorrow, it will get approved. I'm joking. I'm joking.
There's some concern that there are enough interesting edge cases in build systems that you cannot escape having it turn complete language.
No.
But that being said, it's probably true that there's a declarative simpler, especially when you start getting opinion about project structures and file names and stuff. It's probably something simpler to get. But Vito's comment was like, well, some people need to roll up their sleeves and start working, and I don't think
there's no one objecting within the CMake ecosystem to saying let's build the declarative front end that does the easy thing for the easy cases, right? It's a roll up the sleeves and engineering. It's an engineering manpower problem.
And there's even some forethought to it with the bracket escape, so you could potentially put a more declarative language inside a CMake list file. That was some forethought. That was why that part of it.
I still want something I could do code transformation on.
Yeah.
No, it's just to continue what I was trying to ask, and it's like it feels like if we didn't have a CMake.toml where you just say the name and then you just add a section of like what my dependencies are, and we are very, very similar to actually such a nice developer experience. I know it will work only in the cases where we live in the modules world and we'll use latest ever greatest compilers, but still, I mean,
we can get started and you can hit the easy cases pretty quickly. It gets more complicated when you want to do things like cross compiling and code generation. Eventually we'll have to figure out that stuff too. Again, Cargo has a build.rs.
Yes. Build.cpp. No. It's just cool.
All right, there's another pretty cool project out there called Clang Module Converter. This is probably worth people taking a look at. Essentially, it provides 3 styles of rewriting a project. So rewrite a header-based project to provide module interfaces, but still keep the header files, which is known as the header wrapper style, which is kind of what I've been describing here. Rewrite the header to have a module-based one, but still provide the original headers. Helpful if we decide we want new features in the module, we want to keep the old interface, although the two could certainly diverge and then you'd run into trouble. Or you could rewrite a header base into a module and completely trash the header files. And this tool isn't expected to run continuously like Clang format. It's a one and done kind of tool, but probably worth looking at if you wanted to do this on any serious sized project. And it's a Clang-based tool. Essentially how it works. So the core of the tool is the ability to find the preamble section for each file in the project. So to introduce the dependency, for example, so when we're doing it as a module, we don't want to do these pound includes because it's going to show up in that. You can only have those pound includes in the global module fragment. And if we're going to reuse this inside the as a module interface, then you got to get rid of those includes. So you need to be able to push all your includes up. So I guess this helps you find that. All right, some resources. If you want to hear about modules, import CMake, the experiments over. Blog is a good place to look. Craig Scott's got a nice thing up about C++, 20 modules, CMake, and shared libraries. And then I've got some various links, and the slides will be published. So all I'm saying is give modules a chance. Try import stud, create a name module for your project. Let's see if we can train the AI chatbots to get a little better with CMake. Be prepared to build compilers, CMake, and other tools, and install previews. Be prepared for other errors that are caused by doing bleeding edge compilers. Special thanks to Bloomberg Engineering for funding a lot of this work. Brett Brown, Daniel Russo, Ben Bakel. So thanks to David took off without asking his question. Any other questions?
So something I was unfamiliar with, and I think you kind of alluded to was that if I compile a file, C++20, and then my main is C++03, for example, I can link those?
As long as they're not using import stood as a special case, as long as they themselves are not C++ modules, and you don't have any weird ABI incompatibilities between them, which are possible to develop, yes, they can link. Because your platform has some sort of ABI standard, right? It's SysV or Itanium or Twin64. And nominally, those define all the things like name mangling rules and stuff like that. So the C++ standard shouldn't matter under non-pathological circumstances.
So in this case, since we're building with the same compiler at the same time, you wouldn't find these kind of issues between building the library in C++20 and then using C++20, building the library in C++23 and then using C++20 for our main function.
Don't do it.
You will no, like you just want your whole program to use the same C++ version. Like I talked about this in my talk, but like you're gonna someone's gonna include, you know, a boost header that does a different thing depending on whether the C++ macro sets to this value or that value.
But
And
is
then
this
you
what's
got an
going
ODR
on in
violation.
CMake?
Yeah, you get ODR violations and things crash. If you're lucky, you get a bad link.
Is that what was going on though?
Well, in this case, it's simple enough that you're probably not hitting that. So what Vito is saying is like, if you have a really simple program, the standard library itself is maintained to be binary compatible very carefully. Like it'll make duplicates of all the symbols just in case you want one of them, like that kind of stuff. But like the problem isn't that. The problem is going to be the rest of the ecosystem that isn't that careful because it's really hard and no one expects them to be that careful.
Nice.
We actually have this exact same discussion on one of the demons that was currently mentioning as well. I can point you to the thread.
So it's like someone uses TL optional if C++ is less than a certain version, but they use the standard optional if it's greater than a certain version. That's a different ABI.
Okay. Is that what ODR is?
So ODR would be yes, someone has, yeah. So you have one object that thinks it's going to link that symbol, and this other object thinks it's going to link this
Or
symbol.
you embed one of them in a struct and or instead of the other one, they have different layout. Boom.
All right. Okay.
Or
Question in the back here.
Since you're kind of advocating building with modules, like how about we do CMake with modules?
It's not really a library.
If you use CMake as a library, I will find you. No. We have to support C++ 11. All our code has to build under incomplete C++ 11 compilers. So it's going to be a minute. So once modules are what C++ 11 is to us today, that's when CMake will use them.
Or, more interestingly, I've been wanting to do something like VTK, but just haven't had the time. Yeah.
Something that I found interesting that you mentioned, you said that a lot of people use CMake with inconsistent spacing and formatting. And so I'm wondering, is there a canonical CMake formatting that you should be using? Because I myself am inconsistent between files. So I'm sure there must be.
There's various CMake modes in most editors.
But is,
He doesn't care as long as you're
No, but the
yeah.
problem the problem is that if you work in a company with many people, right, and they have different ideas and different setups, right, you don't have a formatter as a tool.
So we need CMake formatter. Right?
Yeah, but it has very little options to format.
There is a CMake formatter project.
Yes,
And
there is
it's-
one, but
it's
it
not
just
maintained
tokenizes and puts each token on a separate line.
Yes.
It's fun. It's fun every time we do a CMake talk because
Standard.
it's always the same 7 questions and I have the exact same answer. Like I have a top 10 list, right?
Put it to the website.
It's like yes, CMake.toml is like number 1, like CMake lint is number 2, CMake formatter is number 3. So yeah, I agree. It would be dope if we had a formatter that had canonical formatting.
I wasn't even necessarily saying
Do
I
a
want there
style
to be
guide.
one. I was wondering if there is one, like already. But
Short
okay.
answer is no.
Yeah.
Longer answer is we like pull requests.
There are open source CMake formatters that's really good. We're using Beeman, but I'm not sure if that's what you're asking.
There's no canonical style guide. There's not like cmake.org/style guide.html anywhere that you're missing.
Very specific link for you to mention. I'm going to go to that.
Yeah.
David, did you still have a question?
Yeah. You
talked about that NSVC wrote some BMI file that was very compatible between versions. Does that imply that he didn't just dump their AST?
Yes, they have an entire open source library that is used, that they published to construct their IXX style modules and their associated BMIs with the sort of coercive hope that the other compiler vendors would.
And nobody signed on.
No.
It's more work. So that's the fun.
Yeah, I understand.
So Galinos Race has a full-length CppNow talk about the format and its hopes for it and stuff.
Okay, so actually, that might be a useful example for other languages to look at, right? Is it? I'm not going to ask you.
The other thing a lot of languages do is they have a very specific expectation about your tool chain. Like there is one, it's common, or it's all using the LLVM/Clang stack is also common. So they will use like Clang modules as the backend for their module system. Under the hood, it's all Clang modules or something. So like that's fine for those ecosystems.
Yeah.
But then we have MSVC, GCC, and LLVM as table stakes in C++. That's not to mention all the other things that might be implemented in this work. So that's one of the challenges. Is like, well, ISC sounds great, but then someone has to fund the open source work to get all the other ones done. And so far, nobody did. If that work emerges, maybe we'll all move to IFC files, and then your Clang tidy can import your VMIs from your MSVC build or whatever. Speaking of which, your Clang tidy has to also parse all this stuff. So, speaking of outstanding work.
Yeah. Clang modules are notionally the same thing, or are they like really a very different beast?
I think they're more akin to precompiled headers.
Yeah, they're closer to precompiled headers than they are to what got standardized as C++20 modules.
In what way?
In that they are a memory dump of the internal compiler state rather than a construction of the AST that gets reparsed.
I think the big difference.
You just described the GCC and so forth.
I think the big distinction is how much preprocessor state affects the of the module. So like in an include, you need all the preprocessor state before, right? In an imported header, you can skip the preprocessor state before, but you affect the preprocessor state after. And I think Clang modules are more like that because they're closer to a precompiled header. Whereas in a name module, there's no before or after. It's just this isolated extension to your AST, give or take. You don't have to worry about the preprocessor per se. So
let's say I have a project that is not using modules, and let's say I am experienced in C++ but have never used C++ modules. If I were to want to add that support, what kind of time commitment do you estimate that would take?
Depend on the library.
Okay.
And how big it is.
Okay.
Right? I mean, if it's half a dozen files, it's going to be really quick.
Okay.
If it's, something like.
And what you're doing. So like the conversion tool you're showing, like you could claim that there's a property of a file that's easier to convert. It's like your includes are at the top and, the rest just, like if you're like that, it's going to be easier. If you do anything else, which you've probably seen people do other things, it's going to be more complicated.
Yeah, and how well the library was set up for export, like controlling symbol export to begin with. The reason that the MSVC STL got away with import stood so quickly is they already had preprocessor designs before every single symbol, and so that they could just redefine those when they're doing a module build, and then it sort of gets. So if you were super disciplined about that, maybe it's gonna be really easy for you. I think
if you have preprocessing entities in your primary interface, it's going to be more interesting too, right? Like maybe some of that could be modular, but then you're still going to have some thought about how you extricate like your include interface so people can view your macros or whatever, and then the rest of it.
So, and the answer to your question is we have no idea.
Great. Like everything in C++.
Yeah.
I think there's still real upsides, and I think Steve Downey gave a talk about this last year about it, which is like the big upsides are the encapsulation and such. Like we just talked about preprocessor state, this and that and the other. Who hasn't been burned by like min and max, lowercase as macros?
Who
Like
I
the
have.
fact that you, right, the fact that you can more locally reason without worrying about what nonsense someone else is doing in their interfaces, there is a pretty big upside at a certain scale. The hard part is just like how do we push past this local maximum to get there?
Yeah.
And is it worth it, right? Versus other things. Right?
Yeah.
So.
No, I mean, this talk has really inspired me to like go do that in my own library so I can learn more and maybe take that to work and like understand how all this stuff works.
Awesome.
This is great.
Thank you.
I expect imports good by itself, even if you can't modularize your own library, would be an interesting experiment and probably the easiest thing to adopt.
Okay.
Import stood is awesome.
Yeah, and it's also a model. I mean, that's why I think you could apply that to your own code easier than trying to like super modularize it, right? Depending on your library.
But you can't import std at the moment because it will break everything because somebody includes the headers and everything breaks, right?
That's a bug, but yeah.
It's a bug.
Yeah, that's a bug.
Okay.
Verify that it works on
So
your.
it would be great, but please don't do it.
Well, verify that it works on your tool chain of
Yeah,
concern.
it may be fixed, and
Yeah.
I think that was some older.
Bill says, like, try it out.
Yeah,
Like,
try
just pile on the relevant issue. People do pay attention to pitchforks, right? I mean, I don't mean pile, I'm joking. But like if there are a million up votes on the relevant MSVC bug report, they'll pay attention to that, right? And if they get crickets on MSV bug report, they'll be like, oh, I guess nobody cares about imports, then we'll do something else.
But yeah.
One quick thing that I may have missed, if you export a module from one target and you want to import the module in another target, is that seamless through CMake?
If you find package and target link libraries correctly, and you install correct, and you do everything correctly,
Okay.
yes.
Okay, so if I'm already doing everything correctly, like before, then it should be fine after.
Yeah, if you look at that compile time regular expression library, that does that, and that example works.
We need extra things. You need to add one extra line to your install to say, I'm installing modules, and this is the directory my modules are going to live in. And if you don't have that, we don't install anything related to modules. So it's not one-to-one. There's a line or two of work. But you can use PCRE as an example. There's you can follow the documentation for install. It has all the things laid out that you need to do.
Or read these blogs that are up. Yeah. They have some nice small examples.
It's worth noting, as far as I know, the only packageable module built system is CMake.
Yep.
I don't think anyone else is bothered.
All right, well, thanks everyone for coming. I think it was a great conversation. It's so much better to do this in person than it is to do it on like a Zoom call or something like that. The conversation was great, and thanks for coming, and go forth and module.